I'm back on that jazz. What's up, party people? First of all, if you happen to be watching this live, do me a favor, like, share, and subscribe. And prior to that, I appreciate you checking this out. If you are watching the replay, do me a favor, put a one in the chat, put a city in the chat where you're checking in from, put something in the chat and let me know you're watching this live. We're back. Unit 6, lesson 5 for my students. And this is actually continuing to look at exponential patterns. Let me turn off this jazz music because you might not be able to hear me. So we're talking about more exponential patterns. And this is going to be important because we're building on understanding how exponential growth builds, the patterns that exponential growth sets, and comparing that to linear growth. Okay, so let's go ahead and get to the right slide because I am off. So exponential patterns, and to get right into it, we're going to start by looking at this right here, and we're just simplifying or evaluating this expression, these expressions here, right? So remember, order of operations is important to this. Remember, you have P, E, M, and D from left to right, A, and S from left to right. I'm not going to draw the pretty version. P for parentheses or grouping symbols, E for exponents, M and D for multiplication and division. I wrote them next to each other because they go from left to right, and AS for addition and subtraction, and I wrote them next to each other because they go from left to right. So let's get into this. First of all, I have 7 plus 2 to the third power. Remember, 2 to the third power is 2 times 2 times 2, okay? And so I have 7 plus 2 times 2 times 2. So 2 times 2 times 2 is 8, and 7 plus 8 equals 15. That's your answer. Here, 3 to the 1 power. Any number to the 1 power is that number. So in this case, 3 to the 1 power is 3, or as I like to say, tree. And 9 times tree is 27. Here, exponents first. So I have 20 minus, remember, 2 in expanded form, 2 to the 4th power is 2 times 2 times 2 times 2. That gives me 20 minus 16, which equals 4. Here, same thing. I got to do exponents first. So this is 6 times 6. So 2 times 6 times 6. So that gives me 36. And 2 times 36 is 72. Here, I have 1/2 times 1/2. And then that's 8 times that, okay? So 1/2 times 1/2 is 1/4. And then 8 times 1/4. If you need a little help working this out, remember, I can turn that 8 into a fraction, and then 1/4, numerator times denominator is 8, denominator times denominator is 4, and 8 divided by 4 is 2. Over here, I need to do exponents first. 3 to the third power is 3 times 3 times 3, and I have 1/3 times that. 3 times 3 times 3 is 27. 1/3 times that. Once again, if you need to stretch it out, just go 1/3 times 27 over 1. 1 times 27 is 27, and 3 times 1 is 3, which 27 divided by 3 is 9. Last but not least, this one looks a little tedious, but you actually have 1/5 times 5 to the 5th power. Now, we can expand this out and write 1/5 times 5 times, but when I look at this, 1/5 times, if I turn that 5 to a fraction and keep it to the 5th power, then that's 5 over 5 to the 5th power, which actually is 1 to the 5th power, and any power of 1 is 1. Take some time, pause these, rewind them. Remember, order of operations. If you need to get a refresher on order of operations, go look up my video, and I may just post that in the notes because that's something that I should do, and you can check out that video, okay? So let's clear this out, and let's get into the exponential growth patterns. All right, so we have another scenario like in the last video. There was a king There was once a king in India, and I'm going to just paraphrase this. There was this king in India who loved to play chess, and he challenged all kinds of visitors that came to his country or his kingdom to a game of chess. Well, he came across this sage, and this sage was like, wait, yo, I know how to play chess. I'm a chess master. And so this sage played all kinds of chess with people all over the world. He accepted the king's challenge to a game of chess. And the king was so confident in his ability of, the king was so confident in his ability to play chess. He told the sage, you can have any reward that you want if you beat me in a game of chess. So the sage was thinking, hey, I got two rewards that I would ask for. And in the first reward, as you can see, reward one, he would ask the king to put 100 grains of rice on each of the 64 spaces of the chessboard. Okay. So if you count those out, there's 64 spaces in the chessboard. And then he said, or I might just say, hey, Mr. King, you can put 1 grain of chess on the first square, and then 2 grains of chess on the 2 grains of rice on the second square, and then 4 on the third square, 8 on the fourth square, and so on and so forth until 64 spaces are filled. So basically, with reward 2, he starts with 1 grain of rice on the first square, and then it doubles to 2 on the second square, it doubles to 4 on the third square, and it keeps doubling until we get to the 64th square. So we want to know, for reward 1, we want to complete this table of values for the number of grains of rice for the first 10 squares. So what we want to start by doing is saying on the first square, there's no rice. On the square number 0, there's no rice because there's no square. So it's a total of 0. All right, so then we have 100 here, and we got a total of 100. On the second one, he puts another 100. We got a total of 200. On the third one, he puts another 100. And as you can see, the pattern continues. Up. I knew it. All right. So we get to 400, another 100, another 100. Okay. So as we can see, there's 100 grains of rice on each square. And as we can see, the total amount of rice, the total grains of rice is adding up. And in the first 10 squares, it ends up being 1,000 grains of rice on the first 10 squares. So if we continue this pattern, when we look at question B, it says, how many grains of rice will the sage have after all 64 squares are filled? Well, if we take 100 times 64, we will get 6,400. Okay, so 6,400 grains of rice. Okay, now we're going to go and we're going to look at the second reward. Okay, and in the second reward, we're going to fill out another table. Okay, so now in this one, he's going to start out with 0 for square 0. We have 0 grains of rice, and we have 0 total grains of rice. So now we have 1 grain of rice here, and then we have a total of 1 grains of rice. That 1 doubles to 2, and 1 plus 2 gives us 3 grains of rice. That 2 doubles to 4, we have 7 grains. That 4 doubles to 8, we have 15 grains. 8 doubles to 16, we have 31 grains. 16 goes to 32, we have 63 grains. Double 32, we get 64, and we get 125 total grains. 64 doubled is 128, and we get a total of 255. Actually, wait, hold up. I made a mistake. This should be 127. I'm sorry. And then we add the 128 to the 127, and we have 255 grains of rice. And then that 128 doubles, and we get 256. And if we add those together, we get 511 grains of rice. And then we double that 256, we get 512 grains of rice. And if we add 512 to 511, we get 1,020. Whoa, I didn't write that correctly. 1,023 grains of rice. Okay, so we completed the table for the first 10 squares. How many grains of rice will the king put on the board for square 20? Notice this number is doubling every time. So we start out with 1, and then 2 is our multiplier. And in this case, for the first 20 squares, we're going to say to the 20th power, and that equals 1,048,576 grains of rice on the first 20 squares. Then we want to estimate how many grains of rice the sage will have on all 64 squares. So we're going to continue that. We started with 1. Our multiplier is 2. And we're going to take that to the 64th power. And if you multiply that number out, it's a very, very big number. But we're going to write this number in scientific notation. It's 1 times 10 to the 19th power. So that's a very, very large number. If you put this in a graphing calculator, you might see 1. Let's see my graphing calculator. So 1 times 2 to the 64th power, and we get 1.84467. And you'll see something that says E19. I'm not going to write all those digits out, but that's 1.84467. And that E there, this E, capital E in a graphing calculator, represents scientific notation. So that's just like saying times 10 to the 19th power. So we see this is a very, very large number of grains of rice. So it's kind of obvious when we get to the next question, which rewards to the sage request? He should start out with the 1 grain of rice and double it every time. Okay. Kind of a debrief with this. You want to ask yourself and be able to answer, what is the difference between linear and exponential situations? So for linear situations, they continue to increase or add up by the same amount every time. For example, when he chose the first reward said he's going to put 100 grains of rice on each square. So the total grains of rice is increasing by the same amount, which is 100 every time. Okay, so linear, it increases by the same amount every time. Exponential, if we look at reward 2, where he started out with 1 grain of rice and it kept doubling. It kept doubling. But notice the total grains of rice, the amount that it increased changed every time, because as he had more grains of rice, the increase in the total grains of rice doubled. So it increased by 1, and then by 2, and then by 4, and then by 8, and so on and so forth. What is the difference between linear and exponential tables? Well, one of the differences between linear and exponential tables is the change. The increase in a linear table stays the same. It just continues to increase by the same amount, versus an exponential table, the numbers increase by whatever the multiplier is. So the amount changes for each square in the table, okay? What is the difference between linear and exponential graphs? A linear graph is exactly what it says. It's a line, okay? So it looks, over time, it just increases like that. A exponential graph increases, if I change this color, it'll start out here like this, and then it'll eventually go up like that, okay? So that's the difference between linear and exponential graphs, all right? Hopefully this was helpful to you all. Let's clear this out. Do me a favor, make sure you like, share, subscribe with a friend. Put something in the chat if you're watching this replay, and especially if you got to this point in the video, put something in the chat. Tell me what city you're watching from. Put a 1 in the chat if you learned something. But just talk to me in the chat. I talk back. And remember, I got the solution to your math problems.